Okay, there we go. You're all still awake. Your brains are on fire, but it's okay because functional programming. So, my name is Ron Garcia. I'm a professor at University of British Columbia, and I have the distinct pleasure of chairing the awards ceremony presentation. So we'll begin with the Student Competition Awards, and then we'll go on to Jeff Foster will visit us virtually to talk about the role of SIGPLAN, and then the Programming Languages Achievement Award will be presented with a short talk, and then we'll talk about we'll announce the most influential paper award from 10 years ago, and I will end with the ACM Europe Best Paper. So let's begin with the Student Competition Awards, and for that I'll invite Donal to the stage.
It should just work. Okay. So, hello everybody, do you hear me? Okay, so as you might have noticed, so first of all, so I'm Donal Ahman, one of the co-chairs, Daniel is the other co-chair, and we organized this year's student research competition. As you might have noticed, over the last few days, this group of great students have shown their posters, have given presentations yesterday, and today we can honor the best three in both of the categories. So 3 places in the undergrad category, 3 places in the graduate category with awards. So we're going to start with the undergraduate category, but before I start, I just want to say that in person, you're going to get a little gift from the organizers here, and afterwards, ACM will send you a monetary award, a medal, and I believe also a 1-year complimentary ACM membership. So this is what you will get afterwards. So the undergraduate category. So we'll start with the 3rd place, then 2nd place, and the 1st place. And I'll ask, if possible, if the student is here, then to come to the stage and we'll hand you a little gift or award. So the 3rd place in the undergraduate category goes to Francis Rinaldi. Are you here? Yes. Okay, the 2nd place in the undergraduate category goes to Hilbert Chen, Yuan Chen, and Eric Zhao. And the 1st place in the undergraduate category goes to Bernard Bowie. So now let's continue with the graduate category. So here, the 3rd place goes to Denis Garnier. The 2nd place goes to Nathan Corbin. And finally, the 1st place award goes to Arthur Goranson. So these were all the awards, but before I finish, I would really like to thank, first of all the participants that we had, all the PC members that did very diligent work on reviewing the abstracts that the students had to submit and also gave lots of good feedback. And finally, also members from the ICFP audience that helped us with judging the posters and the presentation. So thanks to all of you.
Thanks, Donald. So at this time, we're going to have a visitor from, I guess, from Airmeet land, which will be Jeff Foster, to speak to you about SIGPLAN.
You didn't see that.
I didn't do that, everyone. And so
there's Jeff. I can't hear you yet. Let's see if we can get the audio going.
you can't hear me. Okay.
Or we have a delay, maybe.
We have a delay.
Okay, you're good.
Okay, can you hear me okay?
Yes.
Okay, all right, good. And can you see me or not? Can you only see me, hear me, or can you see me as well?
Nice shirt, Jeff.
All right. Sorry. Okay, I can hear myself in the video, so I will just talk and not worry about sharing my screen. So, hi everyone, I'm Jeff Foster, the chair of SIGPLAN, and I will keep this short since we're having some technical glitches. So what is SIGPLAN? SIGPLAN is the Special Interest Group on Programming Languages. You probably already know that. It oversees and runs ICFP, POPL, PLDI, Splash, PLMW, SIGPLAN Cares, SIGPLAN M, and more. We are the fourth largest SIG at ACM with just a little under 2,000 members. And the mission is to promote awareness and advancement of research and practice in programming languages. Sounds fantastic to me. And I want to say SIGPLAN is run entirely by volunteers. So SIGPLAN is us, right? We're SIGPLAN. And if you're interested in getting involved in SIGPLAN and want to help out, please don't hesitate. Please get in touch. We'd love to have your help. I wanted to give you two sort of high-level updates. One, to tell you about our finances. So we spend money on student travel, summer schools, conference management and infrastructure, SIGPLAN blog, SIGPLAN awards, and so on. And I just want to let you know we are doing fine. So despite the challenges of COVID and all the craziness that happened, our conferences are very well run, as ICFP is very well run. And we have comfortable reserves thanks to many years of good management from prior executive committees. So everything is fine in SIGPLAN land, which is good. As you know, in-person conferences are back because you're there, most of you. I'm sorry I couldn't be there. I love in-person conferences and I wish I could have made it. Do expect further experimentation with remote participation because we're still figuring out how to get that to work in the best possible way. A couple other notes. I just wanted a heads up. Conferences are expensive to run and inflation is running rampant worldwide. So do expect registration rates are going to tick up in the future to cover that. Don't be surprised when that happens. I wanted to encourage everyone to have your institution join ACM Open. So ACM Open is the new ACM solution to open access publication. And it's the replacement for the digital library subscription. So your institution, if it joins ACM Open, will have access to the digital library and will prepay for open access based on an average number of papers the institution publishes. So essentially ACM is going open access. This is the way they're going to do it and still exist because they need to have income to make this work. And we have programming languages people at institutions all across the world. So you can go to the folks who subscribe to the ACM Digital Library in your institution and tell them about ACM Open and encourage them to join. and you'll be doing a big service to ACM and the community. I went to the Tufts folks and talked to them, and they joined. So it's not too hard to do. And then one other heads up, ACM has a new system for keeping track of people that violate ACM policies. So there's a database that ACM has called the ACM Violations Database. Don't worry, you are not in it. Okay, so don't be panicked. The only way people are in it is if they will know, because you will get a letter from ACM saying that you're there. And so if someone violates a policy and there's a sanction, it will be recorded in the database, and we will be checking the database for when we ask for volunteers and committee members and so on. So hopefully this doesn't affect anyone listening to this, but I just wanted to make you aware that it is there, and it's a new effort by ACM. So that's it for me. If you have any comments, suggestions, complaints, questions about SIGPLAN, please don't hesitate to get in touch. I'd love to hear from you. All right. Thanks, everyone.
So at this time, it's my distinct pleasure to unveil the the first award to have the first award after the SRC, which is the SIGPLAN Programming Languages Achievement Award. And the winner is Javier Loa. It's my pleasure to invite him to the stage. Okay. And
okay, well, thank you. Thank you very much. It's really an immense honor to receive this Programming Languages Achievement Award. Just looking at the list of previous recipients, I see founding fathers of computer science, like Robin Milner, Tony Hoare, and I also see many of my mentors, scientists whose papers, books, lectures had a decisive influence on my early years, and there's at least one in the room tonight. And so it means a lot to me to be added to that list. And, well, then I'm also especially happy to receive this award at ICFP. ICFP conferences have always felt like family reunions to me, so many familiar faces. But it's also because I realized while preparing those notes that throughout my research career, I've always been doing functional programming of one kind or another. I'll talk about both kinds. Not always the dominant kind at ICFP, but never mind. And then, well, I must say I've always been fascinated by the act of programming, ever since my first encounter with an Apple II computer at the age of 13 or so. My programs never worked, but still I could write a story in broken English and the computer could understand it, okay, and run it tirelessly without complaining ever, very quickly, always correctly. And also was fascinated by the languages and what it takes to implement them. I had this feeling that implementing, let's say, even a basic interpreter was significantly harder than a game of Pong, which was about the extent of my skills at that time. So as a hobbyist and later as a student, I learned a few programming languages, Pascal, Lisp, C, Prolog. And then around 1988, I think I discovered Milner's ML via one of my professors, Guy Cousineau, who was working on the first Camel implementation along with Gérard Huet at INRIA. And I was completely blown. This was the nicest language I've ever seen at that time. It was Lisp with types and pattern matching, Prolog with types and a sensible execution model. It was looking as good as Pascal, but without any of the stupid limitations. So I could really see myself using this language for everything I was interested in at that time. So symbolic computing, advanced algorithm in general, systems programming also. And so at that time, I had heard about pure functional programming, but that was the late 80s, so Haskell didn't even exist. And basically, I didn't see the point. It looked to me like part of traditional British education, cold showers, caning, and Miranda programming. But not something that would help me do what I wanted to do. And at that time, so the late 80s, implementations of ML were actually pretty bad. So my classmate, Damien Deliger, had ideas for better memory management, and I had ideas for better abstract machines. And we were both very admirative of like the Smalltalk virtual machines and things like that. So we wrote a new lightweight implementation of Camel. So it was Camel Light. It was cutting a bunch of corners, but it was highly portable, could run on PCs and Macs of the 90s, which were seriously underpowered. And so it was usable in education and for self-discovery, and helped a lot, I think, popularizing functional programming, especially in the French university system. Then it was rewritten a couple of times, grew a native code compiler, various language features, and became the basis of OCaml, as we have today. So then, well, I did my PhD, postdoc, and early career on, working on type systems mostly, with also special interest in abstract types and representation independence properties, how to combine type abstraction with module systems in the style of standard ML. And then that brought me to language-based security to some extent. For instance, what makes typed programs more secure and not just safer than untyped programs? I still don't have an answer to this question. Then I got interested a bit in Java, via its virtual machine and the bytecode verification problem, which is basically type checking on an intermediate representation. And that's how I finally ran into formal verification using proof assistance. I had this big, like 18 firms rules for one of those bytecode verifiers, and I wanted some assurance. And then I realized that with help from many colleagues that were in Coq, it was just an inductive data type, an inductive predicate definition, and there were good facilities to work with that. And later I also did some mechanization of type systems, mostly for fun, the kind of things that became popular with the Popple-Mark challenge a few years later. But the revelation came around 2004. That was the work of Jean-Christophe Filiatre and Pierre Letouzet, so on verifying the OCaml standard library module that implements finite sets as AVL libraries, AVL balanced trees, sorry. So what they did, they just transcribed the camel code to Coq, then verified functional correctness, balancing properties, etc. Then extracted back to Camel, and it looked almost the same. And for me, it was a discovery that you can also use Coq as a programming language. And I would say an hyper-pure functional programming language, as opposed to Haskell-style merely pure functional programming, where you can still diverge to your heart's content. In hyper-pure functional programming, there's no effects, not even non-termination. So yeah, you have to prove everything terminating. But in exchange, you get functions that are objects of the logic, and that can be reasoned upon directly. So you don't even need a program logic, such as for logic. Your code is already part of your math. And that was an eye-opener to me. And then I thought about verifying a C compiler with this methodology. That we can specify and verify the correctness of compilers, that's an old idea. Okay, 1967, McCarthy and Painter for arithmetic expressions, mechanized by Milner in 72, so in LCF. One of the first mechanized proofs about programming languages was actually a compiler verification. And then in the 90s, we did verified compilers from lambda calculi to abstract machines, work by Ritri, by Pagano and co-authors. Some of that was mechanized in the early 2000s, like Benjamin Grégoire and myself. And well, there was some industrial need for a verified C compiler, as I heard from people in the airplane industry. So how hard could that be? Right. Well, it turned out to be very hard, but unfortunately, I didn't know about a number of failed projects that attempted to do something similar before. So it was tough, but in the end, it worked, and that gave the ComCert a verified compiler. And when you know something can be done, it feels less difficult already. So I think ComCert inspired many others to try their hand at formal verification of compilers, code generators, translators, analyzers, other verification tools. Compiler verification is now a sub-area at the Purple Conference. I know because I'm getting all the submissions to review. And, and back to that methodology of hyperpure programming, well, this plus monads for all effects, including non-termination, is now a standard technique, right? It's how you use ACDA. It's how F* is built around this idea. And, but you can still use program logics, like separation logics, because they can be built on top, like in Iris. So it's really a tribute to the tremendous expressive power of type theory, that we can do all that in the same environment. This said, I still like effectful programming, and I still like to go back to OCaml. And as Casey mentioned this morning in his great invited talk, so OCaml is getting shared memory concurrency and algebraic effects and effect handlers, so even more effects if you want, but principled effects, and that I hope will work well for modular programming as well. So I'm looking forward to the new possibilities this opens. And so in closing, well, thanks again. Thanks to all who worked with me at these adventures, my PhD students, the OCaml development team, the ComCert development team. Well, thanks to you for listening, and thanks again for the award to the SIGPLAN committee.
And thanks to you, Javier. At this time, we'll be unveiling the most influential paper for ICFP. To do so, we'll be visited again virtually by Tony Hosking.
Greetings. I am coming to you from down under in Australia. So it's about 1:30 in the morning here my time. It would have been wonderful to have been with you in Slovenia, but unfortunately that's not to be at this point in time. It's my pleasure to present this award, the award for the most influential paper of ICFP of 10 years hence, so that's from 2012. The important thing to realize about this award is that it is a SIGPLAN award. Each of the 4 flagship conferences of SIGPLAN have a most influential paper award, which is determined by a committee comprising the general chairs and the program chairs of the committee from the 10 years previous, and the general chair and program chairs of the committee from the previous year. So this would have been 2021 for this year. So the committee comes together and they consider the papers that were presented 10 years previously. And they determine the winner, to which will receive an award of $1,000 to be split among the authors of the winning paper. And the judgment here is on the influence of the paper that stood the test of time. So this year's committee are the folks that you see here: Peter Tiemann, who was General Chair in 2012, Robbie Findler, who was Program Chair in 2012, Suk-Young Ryu, who was General Chair last year, and Ron, who's on stage there, who was the Program Chair last year. It's my great pleasure to say that the winner of the Most Influential Paper Award for this 10 years ago, 2012 ICFP, is Addressing Covert Termination and Timing Channels and Concurrent Information Flow Systems by Dejan Stefan, Alejandro Russo, Pablo Buiras, Amit Levy, John Mitchell, and David Mazieres. I'll just read out this citation briefly, just because it summarizes the grounds for the award. This paper is among the first to describe covert channels caused by termination and timing in concurrent programs, and it presents a mitigation strategy. It has received attention in the general security community beyond the usual range of ICFP papers. There are several follow-up papers that build on its insights and extend the results to more general settings. It presents a dynamic information control system that eliminates termination and internal timing covert channels while mitigating external timing, all without relying on cooperative scheduling. It achieves this by running potentially sensitive actions in separate threads. The system is implemented as a Haskell library using labeled concurrency primitives and demonstrated in an example server-side web application framework with untrusted client applications sharing a persistent key value store, showing how the library addresses potential timing and termination leaks. And I believe we have one of the authors present at ICFP who's going to be able to accept this in person on behalf of the others. And I know some of the others are also watching this presentation now. So if I believe it's Alejandro is going to come up to speak or to receive the award.
All right. Thank you very much, everyone. Thanks to Tony. So I'm speaking on behalf of my co-authors, where we are all pretty honored and grateful for this recognition. Thanks the ACM SIGPLAN committee for that. Let me tell you something about this paper that perhaps nobody besides the co-authors knows about this. This paper already was special for all of us. Now it's even more special, but let me tell you why. We submit the paper, it comes the rebuttal phase. There were some things to clarify, some things to argue for. We did it. We thought we did a pretty good job. We sent it. And then we were expecting positively either conditional accept or accept. Can you guess what we get? None of them. We got conditionally reject. What does it mean? Does it mean we were all confused? Like, what does it mean? It means like, do we need to do the changes to be finally rejected? Right? But anyway, so after we figured out what it means, actually means the same as a conditionally accept, but in a different way. It means like, please do these changes, otherwise you will be rejected, which sends a stronger message, a more motivating message for that, right? So, yeah, so by then, we really appreciate the rebuttal phase. It really helped us out back in 2012. And now we're standing here receiving this award. We are even more convinced about that. So, yeah, so on a personal note, I would like to thank all the community because this community was one of the most influential communities in my personal career to become a scientist when I was back in Argentina with not access to functional programming research. So thanks a lot for that. Okay, again, thanks a lot, ACM SIGPLAN. Thanks everyone for this recognition. We are super grateful and honored for that. Thank you very much.
Okay, at this time, we'll be presenting the ACM Europe Best Paper Awards, aka the ICFP Distinguished Paper Awards. So the Best Paper Award is that for outstanding technical contributions to ACM conferences taking place in Europe, recognition of contribution to the area, and the winners were selected by the conference program committee, and each paper will receive each author will receive a certificate, and the authors of the paper will receive €1,000 to be split among the authors. Yeah, I know. Okay, so our first award that I'll hand out is for normalization for Fitch-style modal calculi. The authors are Nachepan Valyapan, Fabian Ruch, and Carlos Torme Cortinas. Okay, and our second paper is Program Adverbs and Plun Embeddings by Yao Li and Stephanie Weirich. Our third ACM Europe Best Paper Award goes to Multitypes and Reasonable Space by Beniamino Acciatoli, Ugo Del Lago, and Gabriella Vanoni. Can one of you get this? Get this to Gabriella. Okay. Thank you. And last but not least, we have to disentangle the awards, is Entanglement Detection with Near Zero Cost by Sam Westrick, Jatin Arora, and Umut Akar. Yeah.